Welcome to the Explainer. Today, we're stepping into the arena for an absolutely epic tournament showdown. We are talking about Enterprise Application Integration, or EAI framework maintainability. Look, if you build software, you already know the drill. Keeping things running smoothly as systems just keep growing, it's a massive headache. So we're going to throw some real heavyweight frameworks into the ring and see exactly how they stack up when put to a relentless empirical test. And that brings us to the ultimate question. The one that literally drives decision paralysis in software architecture today. Which integration framework is actually the easiest to maintain over the long haul? I mean, we all know that picking a framework on day one might feel like a breeze, but living with it, debugging it, and trying to adapt it 5 years down the line, yeah, that's where the real pain kicks in. Okay, let's dive into this. Here's how our showdown bracket is going to unfold today, so you know exactly how we'll crown our winner. First up, we'll look at the integration problem. Then we meet the competitors, lay out the rulebook and protocol, and check out the hard data in the tail of the tape. After that, we reveal, and the winner is, before finishing up with 5 years of evolution. So, moving right along to Section 1, the integration problem. Let's talk about why EAI is such a headache. As we all know, enterprise application integration is basically orchestrating a heterogeneous set of applications for data exchange and functionality reuse. It's that familiar, often painful art of forcing disparate on-premise servers, cloud services, and mobile apps all running on completely different operating systems to somehow talk to each other. Integrating them is absolutely necessary, sure, but it is incredibly complex. Because think about it, in the old era, AI was primarily about structured data manipulation, right? Just neatly organized packages of data moving through very predictable channels. But the modern era, totally different beast. Today, these frameworks are literally demanded to handle unstructured and large volume streaming data. We're talking video analysis, natural language processing, massive continuous data streams. Adapting an existing framework to handle this kind of tectonic shift requires an intense amount of effort, which is exactly why framework maintainability is so absolutely crucial right now. All right, let's jump into Section 2, Meet the Competitors. We've got 4 open source tools to look at. Here are the 4 open source integration frameworks stepping into the ring today. We've got Apache Camel version 2.17, Spring Integration 4.3, Mule ESB 3.8, and Guaraná 2.0. Now, to keep this analysis completely fair, the researchers didn't just look at every single custom adapter or random plugin out there for these tools. Instead, they specifically analyzed the source code of their core packages, that essential foundation that handles the exact same basic functionality across all 4 frameworks. Which brings us to Section 3, the rulebook and protocol. How exactly do we measure maintainability? Well, the researchers didn't just guess or go off vibes. They actually grouped 25 different maintainability metrics into 4 very distinct categories: size metrics, coupling metrics, complexity metrics, and inheritance metrics. When you put them all together, these metrics determine the true on-the-ground effort required to understand, debug, and adapt the software. For instance, size looks at your classic lines of code, while coupling measures just how heavily dependent different pieces of code are on one another. And this brilliantly illustrates the strict 4-step methodology the researchers use to ensure these rankings are completely reproducible. First, setting up the environment. Second, carefully collecting only those core packages we talked about. Third, extracting the raw metrics using specialized tools like iPlasma and metrics. And finally, computing the ranks using some seriously robust statistical analysis. Okay, Section 4, the tail of the tape. Let's look at the raw data drops. Just think about this number for a second. 119,418 lines of code. That is the staggering size of the core package of Apache Camel alone. Now remember, in software engineering, more lines of code generally equals more potential for bugs, a lot more time spent reading that code, and way more difficulty when adapting the system to new paradigms. I mean, that is just a massive footprint to maintain. So we really have a true heavyweight versus lightweight matchup here. On one side, Apache Camel sitting at nearly 120,000 lines of code, and on the other side, Guaraná with an incredibly lean 3,504 lines of code. When you're the engineer trying to track down a critical bug at 2 a.m. or adapt a framework for a brand new streaming pipeline, an immensely smaller codebase like that often translates to significantly easier debugging and much, much faster maintenance. Now let's look at Macabe cyclomatic complexity, or MCC for short. This basically measures the complexity of the underlying algorithms inside a method. The widely accepted recommended limit for MCC is a score of 10. Yet look at this. Apache Camel, Spring Integration, and Mule ESB all massively exceed this limit, scoring 64, 33, and 39 respectively. Honestly, that indicates some incredibly dense logic. That is a heavy, heavy cognitive load for any developer to untangle. But check this out. Guaraná manages to stay entirely under that recommended complexity limit, maxing out at a score of just 8. For developers on the front lines, this hits right at a major pain point. Lower complexity means it's significantly cheaper and easier to test, to debug, and to safely modify the code without accidentally breaking something else in the process. So Guaraná takes a definitive lead here. Moving right into Section 5, and the winner is time for the statistical ranking. To eliminate any potential bias from skewed data or weird outliers, the researchers applied Iman Davenport and Bergman-Hummel statistical tests across all 25 of those metrics. And the empirical results? They are definitive. Guaraná takes the absolute #1 spot for maintainability. In fact, the test statistically tied Spring Integration, Mule ESB, and Apache Camel for second place. It's a really striking verification that leaner, less complex architectures genuinely win the maintainability race every single time. Finally, Section 6, 5 years of evolution. Let's talk about growth and bloat. Now, what's really interesting to see here is the sheer velocity of growth. Over just a 5-year period, Spring Integration experienced an explosive 121.98% growth in its lines of code. It literally more than doubled in size. Apache Camel also nearly doubled, with over 91% growth. It seems as frameworks race to add all these shiny new features to handle modern, unstructured data, their core architectures are bloating at incredible speeds. And you know, this evolutionary bloat has a very direct impact on the rankings. When you compare the historical data to the current data over this 5-year span, Mule ESB actually managed to improve its standing and moved up a spot, while Apache Camel dropped in the overall empirical rankings. But the standout story here has to be Guaraná. Even though it grew in size itself over those 5 years, it managed its architecture well enough to completely retain its undisputed #1 spot. Which really leaves us with this final, kind of provocative thought to consider today. As these frameworks inevitably continue to grow in size and complexity just to handle ever-increasing volumes of unstructured data, can they truly remain maintainable? The data we've seen today shows a constant, really intense battle between expanding features and long-term maintainability, and that's a trade-off every single architecture team is gonna have to face head-on. All right, thanks so much for joining me on this deep dive into framework maintainability, and I'll catch you on the next explainer.